It is 7 o'clock. Everyone can find their seats and we will get going here. So welcome everyone to the April 2025 meeting of the Minnesota Astronomical Society. My name is Waltz Treybergs. I'm the president. And this is the April meeting, monthly meeting. So for the agenda today, we're mixing it up a little bit. Hold on a second here. We're mixing up our agenda a little bit because our featured speaker, Dr. Humphreys, has an engagement later this evening. So she requested to move her presentation up. So we're going to start her presentation at about 7:30-ish. We'll do some of the introduction stuff that we normally do, and then we'll jump right into the Dr. Humphreys talk. And then after she's done talking and her Q&A, then we'll get back into some of our other things, including the treasurer's report, update on one of our site updates. Mark Job's going to do a site update on Cedar Creek. And then Craig Waynert's going to do a brief little member presentation that should be fun about outreach at the Minnesota Renaissance Fair. And then we'll have a wrap up for the rest of the day. So let's get started here. So this is the 2025 MAS board. As I said, I am Volz Treyberg, your president. John Zimmich here, vice president. Claire Weaverling, your secretary. Noha Reda, treasurer. And board members at large, Jesse Palmer and Phil Ramsey. All of us are here. So and if anyone has any questions about the operation of the club or anything like that, please reach out to us. There's a drop-down form on the website, mnastro.org, in the About, in the board and contacts page. That's how you can get a hold of anybody on the board. So that is the 2025 board. All right, membership. So Steve gave us an update on our membership. So we've got 745 total members in the club as of right now. 3 honorary members, 167 patron members, 540 regular, and 35 student as of April 1st. And welcome new members. This is a list of new members since the last monthly meeting. So is there anybody on this list, either new members or returning members coming back for the first time? Anyone here or on Zoom? Raise your hand. Yeah, what's your name, sir? Welcome, welcome. Anybody online that's new? Feel free to speak up on Zoom. All right, very good. Oh yeah, so Noha is she's got a sweet tooth apparently. So she's brought treats for everybody. So people on Zoom are missing that out on the treats. All right, so welcome everybody, and uh, there you go. All right, so if there's any questions about the membership, membership at mnastro.org goes right to our membership coordinator, Steve Emmert, and he can answer questions about membership and everything. All right, so as normal, we kind of go through a series of Astro events that are upcoming here in April, and this is just a brief list of stuff that I've compiled from inthesky.org and some other online resources. So April 5th, conjunction of Moon and Mars coming up. So Mars and obviously the Moon every month goes by, and Jupiter's still high in the sky. April 12th will be the full moon. Conjunction of Mercury and Neptune. I don't know if that's a morning thing. If you get up in the morning. Last quarter moon, April 20th. Mercury at greatest elongation in the west. Or is that actually in the east now? It's in the morning. Okay, that is correct. That is correct. All right, April 21st. Also, this month, Lyrid meteor shower peak, April 22nd. I think it's not going to be the best favorable condition because of the moon, but it's still going to be, it's always a good show. April 24th, Moon, Venus, Saturn, Mercury, pretty close together in the morning sky. April 27th is the new moon. 29th, Moon is close to the Pleiades and also close to Jupiter. They're all kind of in the same area. And me being a space buff, some upcoming space missions events that are happening. Approximately April 20th, the NASA Lucy mission will be doing a flyby of asteroid Donald Johansen. So that'll be interesting. Get more imaging of another asteroid. And then SpaceX is launching the CRS-32 with ESA's ACES experiment on board. So that's going to the resupply mission, the International Space Station. And then ULA is planning on a launch of another third launch of their Vulcan rocket, methane-powered rocket for the U.S. Space Force. Yep. May 1st, yeah. Okay. Comet Swan. Okay, be on the lookout for that. Suresh gets treats. All right. While we're talking to Suresh, we can talk also about the beginner special interest group. So if you want to pass the microphone on. All right. So there's two events coming on. Suresh, you want to take them both? They're both covered in this slide.
Is Jerry here? No.
No, I don't think so.
So we actually have two big BSIG events coming up. It's our transition month each year. The first one is on April 12th at 1 o'clock. Zoom presentation by Jerry Jones. So about a month ago, I asked him to just speak up and see if he can get people back out again, after a long winter. So he's going to present on some of the Astronomical League programs, kind of again designed to get people back outside, observe some galaxies and the like. And then, weather permitting, Saturday, April 19th will be our first outdoor observing session of the year at Metcalf Field. The April one's always this never can tell if the field will be dry in time, but we're going to try for an April 19th, weather permitting. So as usual, as always, we always need volunteers to come and help us, bring a telescope and
yeah, come on out. If you've got a new telescope and you want to learn how to use it, bring it out. We'll have plenty of help you to learn how to use it, or help to collimate it or set it up, or you just have questions about it in general, or if it's just a fun time to go out there. As you can see, there's a picture from last year, and you can have up to 100 people there, dozens of scopes out there. You can look through different kinds of scopes and just ask lots and lots of questions. It's a really good fun time. All right, that's the BSIG. Also, Michael Cowper is hosting Planets in the Park. That is tomorrow. I don't know what the weather is looking like tomorrow, but that is in South Minneapolis at Pershing Field Park, 3523 West 48th Street in Minneapolis. So that's also a free, open to the family event, right in the heart of the city. So clear, cloudy. There'll be people there. It'll only be canceled if there's a storm or if it's really bad. I don't know if Michael, you're online. If you have any words to say about Planets in the Park.
No, what you did, that's your announcement is just perfect. We're sure it's going to be totally overcast, but we're going to be there anyway. I put something in the chat, in the group chat that you can read. If anybody shows up, we're going to have a good time. People like learning the star wheels, and they like the stories that come from all over the world. Thank you very much for the announcement. That's it.
All right, thanks, Michael. All right, other MAS events that are coming up. Observing season is starting to get into full swing. So we mentioned Planets in the Park already. That's tomorrow. ELO Public Star Party, Saturday, April 5th, 7 to 10. I believe we've got a speaker, and that speaker is Mr. Neverman right here. Is that correct? All right. And also April 5th will be our first Cedar Creek Star Party. We'll get a little preview from Mark Jobe about Cedar Creek a little bit later in the presentation. But that'll be our first Cedar Creek Star Party. And then we already mentioned the BSIG Winter Zoom presentation by Jerry Jones, April 12th at 1 p.m. Then LLCC will have member observing weekend open April 18th and 19th. That's the first of two this month. The second is April 25th and 26th. And then at Cherry Grove, we'll be hosting the Virgo Venture. Unfortunately, the Messier Marathon was canceled because of weather last month. However, hopefully the Virgo Venture will be a go at Cherry Grove on Friday, April 18th. And then we also mentioned the BSIG observing session at Metcalf, Saturday, April 19th at 7 p.m. And then another ELO Public Star Party, April 19th, also at Eagle Lake Observatory in Norwood Young America. And then don't forget about the NCRAL conference, which is April 25th and 26th in Minnetonka. And then the next monthly meeting will be here at the Education Center, Thursday, May 1st at 7 p.m. So there are a couple key holder trainings scheduled for April. So at ELO, April 19th, and the sign up for key holder training at ELO is on the website. So you can navigate to facilities, ELO, and there's a form you can fill out, and then you get information about the training. Yep, get it done sooner the better, so the trainers can get all the stuff prepared and be ready for you. And then approximately April 12th, there's a planned training session at J.J. Casby Observatory, and that sign up is on the forum. Is that still a go, Clayton? Everything still tentative? Good? Okay. And then Cherry Grove, April 18th. That's also a forum sign-up opportunity for key holder training. So for LLCC, the only key holder training scheduled this year is during Northern Nights Starfest. However, I think if you ask nicely on the forum, I'm sure if somebody else, some of the existing key holders go up there during the day, during one of the open weekends, we can perform a private key holder training as well. But technically, the training sessions are during Northern Nights Starfest. So those are the key holder trainings scheduled for April. All right. So by request, we've got now our featured speaker. We're putting our featured speaker right now. So Dr. Roberta Humphreys is going to talk about fun with Red Supergiants. So come on up. We'll get you set up, and we can get you going here.
Well, good evening, everybody. A brief introduction. I'm Professor Roberta Humphreys at the U of M. I've been there a long time. One of the things I really like is big stars. I like them very big. That's the title of this talk, about fun with red supergiants. And I have a few stories to tell about those red supergiants, particularly my favorite one. But suspect you've probably heard some of what I'm going to talk about previously, because one of the stars I'm going to talk about has, of course, made headlines in the last few years. But first of all, I thought I might begin with, in case you don't know it, red supergiants are very big. They are the largest stars known. They are massive stars. They have a lot of mass, typically upwards of 10, 15, 20, 30 solar masses, but they're not the most. Okay, good. Well, I wanted to basically start by pointing out this slide here at the top, one of these silly things you find on the internet, but it gives you some idea of the relative sizes of the red supergiants. That arrow down there is supposed to be the sun. Well, up here you have some stars you may have heard of, like Deneb. There's Antares. This, by the way, is a yellow hypergiant. That's why it's shown as yellow. And my favorite star that I'll get to a little bit later in the talk is BY Canis Majoris. But one of the things I was saying was that red supergiants aren't the most massive stars. Now, I don't know how many of you have heard of what astronomers call an HR diagram, named for two famous astronomers, the early 20th century, Hertzsprung and Russell. But basically an HR diagram, which you see here, is very simple. It's a simple plot of luminosity versus temperature. And you can think of luminosity as sort of a measure of mass, because the two are strongly correlated. And what I've shown here is the HR diagram for the luminous star population. the massive stars in the Large Magellanic Cloud. Large Magellanic Cloud has an advantage over the Milky Way in that the stars are all at the same distance. So you don't have to worry about variations in distance, and so they're all the same distance. It's easy to determine their luminosities, and that's a color-coded HR diagram that myself and one of my collaborators, John Martin at the University of Illinois, we made this for our study of the luminous stars in the LMC. It's color-coded. The hot stars are dark blue, sort of intermediate temperature hot stars are lighter blue. Then the green ones are the A-type supergiants. Their temperatures around 8,000, 9,000 degrees. The yellows are the yellow stars, temperatures like the sun, 6,000, 7,000 degrees. And of course, the red are the red supergiants. And what you might notice there, let's see, okay, is that there aren't any stars up here. Okay? There's something funny going on. Normal stellar evolution would take a massive star on the main sequence, that's hydrogen burning main sequence, and it would evolve eventually over time, using up its hydrogen, turning it into helium to become a red supergiant. And 50 years ago, well, I guess maybe more than 50 years now, that was the normal expected evolution of all of the massive stars in the HR diagram. Okay, it was the expected evolution of these stars as well, until it was discovered that there were no red supergiant counterparts to the most luminous, hottest stars. In other words, there was actually an empirical upper luminosity boundary to the HR diagram. So that does mean that for red supergiants, there is an upper limit to their luminosities. There's an upper limit to their masses, which is about 30 times the mass of the sun. 35 times the mass of the sun is for the most massive red supergiants. So, as I said, the red supergiants are not the most massive stars, but they are the largest stars, okay? Because of their high luminosity and low temperatures, that's why they're red, 3,000, 3,500 degrees, they are big, okay? And some of the stars, the one I like the best, is a radius of about 7 AU. Okay, that puts it between the orbits of Mars, I'm sorry, the orbits of Jupiter and Saturn. Okay, so that's what now you understand what I meant by big. Okay, now see. Next slide. Well, what I'm missing something. Okay, what I really wanted to start with is something you all probably are very familiar with. Remember the great dimming of Betelgeuse back in end of 2019, beginning of 2020. So you probably remember this happening, okay? January 2019, there's Betelgeuse. A year later, there's Betelgeuse, and there's something blocking the southern hemisphere of Betelgeuse. So what happened? Here's the light curve. And amateur astronomers played a major role in, I think, the observations of Betelgeuse. This is actually the light curve from the AVSO. And there you see the dimming. It faded by over a magnitude. It wasn't very long lasted about 2 months or so. But the question was, what was the cause? And there was a lot of debate. I mean, there were headlines, is Betelgeuse going to go supernova, et cetera. You know, people were all excited. Something was happening to Betelgeuse. Well, as we now know, based on the fact that one of my colleagues, Andre Dupre at Harvard, had been observing Betelgeuse for a long time with the Hubble. And actually, fortunately, just before this happened and during it, she had Hubble time, had gotten spectra in the ultraviolet. And what her spectra had shown was coincident, or actually occurring just before the dimming, shortly before, there was a large gaseous outflow from Betelgeuse at the same time. And as that gas expanded, it got moved away from the star, the gas condensed into dust, and the dust obscured Betelgeuse for a short time until the cloud of gas and dust moved out of our line of sight. So One of the things people were interested in, of course, was what did Betelgeuse look like afterwards? Was there any change in its appearance? And there was, during the event, there was a somewhat cooler photospheric temperature, a the famous period, the 400-day pulsation, Betelgeuse had decreased or even kind of disappeared for a while. And as I said, there was a sort of maybe a disappearance of the 400-day period. You have a slide that shows that. Here's again the great dimming of Betelgeuse. This is the light curve here. And you see, here's the 400-day period shown here in the dashed lines. That's what people were expecting to see. And here it is right before the dimming. There's the dimming. And then afterwards, it really didn't come back. And it still has not come back yet. I checked the AVSO. It's getting better. It's getting closer. So the pulsational period is returning. So what happened? There was some kind of gaseous outflow from Betelgeuse, okay? Now, in the previous picture, maybe I should go back to that to point out that's a clue to what happened, is this picture right here. That's an image from the Hubble Space Telescope of the atmosphere of Betelgeuse. It has what astronomers conservatively like to say are asymmetries on its surface. In other words, spots, okay? Betelgeuse has spots. Now, you're all familiar with sunspots, but a spot on Betelgeuse is probably about as big as the sun, right? These are giant convective cells. And what happened on Betelgeuse was, you all heard of coronal mass ejection? Think of a coronal mass ejection scaled up by about a factor of 10 to the 9th, about 1 billion, and you have what happened on Betelgeuse. Okay, so that's what we really think happened on Betelgeuse. But the question about Betelgeuse is, well, did that actually, I should have mentioned earlier that red supergiants are famous for their mass loss. They're big extended stars, and it doesn't take a lot for material to basically move away from the star, okay? Escaping the gravity, material moves away from the star, gas, gets far enough away from the star, the temperatures drop and forms dust. And so red supergiants are famous for being dusty. They have circumstellar dust. So the question was, well, how much mass did that single outflow contribute? And there were some estimates of it, and it was of the order of 10 to the minus 9 suns. Well, that may not sound very big, but 10 to the minus a billionth of the sun is still a pretty good sized chunk of material flowing outwards. Well, one of the things that my colleague Terry Jones and I did was that we decided to look into the mass loss history of Betelgeuse. And it turns out over the previous several years or so, people have been taking images of Betelgeuse in the infrared. This is a 13 micron image. So it's imaging the dust. Out there in the infrared, you're looking at the dust. And what they found with these high resolution imaging on the VLT down in Chile, the VLT telescope, it's one of the telescopes of the European Southern Observatory, is they found evidence for several clumps of dusty material. Indeed, there were actually 6 of them, 6 clouds or clumps, and they're emitting in the infrared. So using that, we estimated the total mass in these clumps, and we found that the total mass of these 6 clumps, which were ejected, we could also estimate when they were ejected from their motions, their velocities have been measured. So we had estimate their mass, summed it all up for the 6 of these clumps. It was a few times 10 to the minus 8 suns, which meant that actually it's contributing about 20% of Betelgeuse's total mass loss. Well, this is kind of an interesting result because mass loss from red supergiants is known, and there's a lot of models, theories about what drives it. Simply radiation pressure on grains, on the dust grains, pulsation can drive mass loss. Convective activity, as we've seen here in this example, can drive mass loss as well. So the fact that there's significant mass being thrown out by these red supergiants in these discrete outflows, discrete ejections happening, is important for understanding the mass loss in these stars. So we have Betelgeuse, nearby star, bright star, excellent example of this phenomenon. Well, how rare is that? Well, it's not very rare. At least only a few years later, we found another example. It was a dimming of not a red supergiant this time, not an M star, but a K-type hypergiant. It's a K-type star in the spectral classification scheme, so it's a little bit warmer than Betelgeuse, but again, very high luminosity, a star known as RW Cephei. So actually, it's the AAVSO that had noticed, or they had been notified by the amateur astronomers that something funny was going on with RW Cephei. Okay, as you can see, its light curve here, this is from the AVSO again, beginning about 2 years before, the star had slowly declined by almost a magnitude over a period of about 2 years, and then had these sudden rapid fluctuations. Zooming in on that, you can see, in fact, I think probably a fair amount of measurement error in these observations as well. But the interesting story is that I actually was contacted by an amateur astronomer. He said, "You have observations of RW Cephei." I said, "How does he know I have observations of RW Cephei?" Well, he looked at one of my published papers. Then one of our papers, again with Terry Jones and one of our grad students, had listed RW Cephei, although we didn't figure it, didn't play a major role in the paper, but we had these infrared observations of RW Cephei. And so we dug up our old observations and took a look. And yes, as I said, we had these observations, and they were obtained with the Sophia. You remember? I don't know if you remember Sophia. It was a NASA where they had a telescope in an airplane, and it cut the side out of the airplane and stuck the telescope out for the side of the airplane. Well, they closed down Sophia a few years ago. But anyway, we had observations, including RW Cephei, with the Sophia instrument. And so based on the infrared observations we have, I won't go too much detail. This is what we call a spectral energy distribution. And this is the visual light area over here. Out here, these longer, higher wavelengths, this is the infrared. And not surprising, RW Cephei had a significant infrared excess. It had a lot of dust around it as well. And here's the image showing the extent of the dusty envelope around RW Cephei. So we were able to estimate the amount of dust associated with that dusty envelope at a current mass loss rate of almost 10 to the minus 5th suns per year. So that's a very high mass loss rate. But even probably was good. This excess out here at even longer wavelengths beyond 20 microns told us that probably the star has had high mass loss for a long time and has probably experienced, in this case, a high mass loss episodes prior to that time. But in addition, we weren't the only people who noticed that RW Cephei was doing something strange, and a group of astronomers at the Chara Array. Have you ever heard of Chara? It's the Center for High Resolution Astronomy. Chara, C-H-A-R-A, okay? It's the Chara Array. It's an interferometer on Mount Wilson. It works in both the visible and in the near infrared. They do interferometry, which means they can measure the diameter of the star, okay, and actually even image the surface. So, using the Chara Array and combination of near infrared photometry and spectra, they were able to demonstrate that during this minimum that RW Cephei was experiencing, it had gotten cooler and had gotten redder. And this is their light curve from their Chara observations. Here's the dimming beginning, and here's the deep part, okay? Here's their spectral energy distribution, similar to ours, with this long wavelength excess due to cool dust around the star. Okay, so they were confirming actually the observations we had seen, and they had even something that very few people had. They had an image. That's RW Cephei from Chara, and it's the first interferometric images of RW Cephei from only about 3 years ago. And what you see here, actually, this is the H band and this is the K band, two different bands in the near infrared. One at about 1.5 microns, the other at 2 microns. And what does it have? What do you see there? What are these things? Surface asymmetries. In other words, spots on RWCPI. So it has an active surface, similar to Betelgeuse. So we've seen two examples of these dimmings, very likely associated with gaseous outflows, obscuring the scar briefly, making it look fainter for a while, and then it recovers, okay? But it's not the only one. Those are not the only two. In fact, what we're seeing more and more evidence now among the highest luminosity red supergiants for these high mass loss episodes that are driven by surface phenomena. And so I want to say a little bit about the one that's my favorite star, VY Canis Majoris. And that's a Hubble image of VY Canis Majoris. The star is right there. You can't see it. It's obscured by circumstellar dust. This image, I should have put a scale on it, is the extent of the nebulosity. This is its circumstellar nebulosity, is about 10 arc seconds across. So it's big. It's very large. Notice several very prominent arcs here, 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 and large clumps of several small knots much closer to the star. Well, one of the things that we did with our data on VY Canis Majoris, we observed it twice with the Hubble Space Telescope. So we were able to measure what we call the proper motion. That's the motion of a star across your line of sight. So if you get two epochs, two images separated by several years, and the star is moving, you can measure that, what we call the transverse motion or the proper motion of the star. So we had done that, so we knew how fast the star was moving across our line of sight, and knew how far away VY Canis Majoris was. We could actually determine when these features were ejected. The oldest one, like this one we called Arc 1, was about 800 years ago. And as you can see, it's had several of these outflows and other clumps of knots and stuff closer. In fact, we collected from the astronomical literature a historic light curve of VY Canis Majoris. And I want to show out some interesting things about this. This is 1800, okay? These are visual eye estimates, not measured with a camera, not measured with an electric photometer or CCD. These are visual eye estimates. So this is the V band. Back in those days, the astronomers were really quite good at this. They had very good accurately estimate the brightness of the stars. Now, I don't know if you can read that well, but that point right there, it's just a little bit fainter than 6 magnitude. VY Canis Majoris, back in 1800, 200 years ago, was nearly a naked eye star. But you can see from these observations here, it had several of these dimming events around 1870, at least 1, 2, 3, maybe a 4th. Okay, several dimming events, like what we say with Betelgeuse and RWCPI. Okay, and then it did something funny. It seems to have lasted a while. It also faded again down to about 2 magnitudes. Faded about 2 magnitudes. Okay. Now, the next set of data we have is actually from the Harvard plate collection. And these aren't visual eye estimates. These are photographic measurements from the photographic plates that they've been taking at Harvard since 1890. They have plates covering the period from 1890 up into the 1950s. And these are photographic emulsions. How many of you people have seen a photographic plate with stars or galaxies? Good. Now you know what I'm talking about. Okay. All right. So, and these are blue because they're photographic images. Okay. And what do we see in the beginning around 1890? And then in 1890 or so, 1900, and up until now, the star is about 2.5 magnitudes fainter than it was in 1800. Why is it fainter? It's had these episodes, these high mass loss episodes, these outflows, and a lot of dust is in front of the star now. In fact, BY Canis Majoris may have been nearly naked eye in 1800. It's not now. Visually, it's about 8 to 8.5 magnitude now. And these are photographic magnitudes, so that you're seeing it, it's in the blue instead of visual, so it's fainter, around 10th magnitude. But notice, look at this. Look at all of these dimming events. In fact, there are about 6 of them. Now, these are different from Betelgeuse, very different. The star is fading not a magnitude, but more than 2 magnitudes. And the duration of those events, instead of a few months, is years, 2 to 3 years. So the dust, the material that was expelled, formed in front of the star and dimmed it by several magnitudes. It then recovers and then has another outburst and another and another and so on, okay? Until it's now settled down again. Oh, but I went and checked the AVSO and, well, here it is again, okay? In around 1980, 1990, it had a couple of these dimming events, not as extensive or deep as they were back 70 years before. So VY Canis Majoris, it's one, I should emphasize, it's one of the most luminous known red supergiants and is probably the most largest star we know. It's the one with the 7 AU radius. Yeah.
I see the dimming event, but it also looks like this magic 40, it got pretty bright after the dimming event.
1940, okay. Yeah, it does look like it brightened a little bit there. Yeah, so it could have brightened a little bit there. Actually, these are some measurements that a person did by hand. I didn't do these measurements off the photographic plate, but another astronomer did and published them. So he was going back to the original plates and estimating the magnitudes. Yeah. I should mention that Harvard, the observatory at Harvard, has now digitized their photographic plate collection, completely digitized it, and you can access it online. The name of the project is DASH, capital D, capital A, capital S, C-H, DASH. Look up Harvard DASH, okay? And they've now got a complicated, and I find it complicated, online search engine, so you can search the plates. You can actually get the whole plate if you want, but they've gone in and done the hard work for us. They've measured the magnitudes. So if you're interested in a variable star, you can go to this site, and if it's and it includes the northern and southern hemisphere, because Harvard had those patrol telescopes in both hemispheres beginning around 1900, okay? So it's your all sky coverage down to about, it depends on which telescope was used and what observatory, but down to at least about 12th or 13th magnitude. So if you have a favorite variable star and you'd like to know what it was doing around 1900, you can go to that site. Okay, so I'll just give you that as a little background. I think for amateur astronomers, that may be a very useful site to know about. But as a result of the work we did on VY Canis Majoris, the Hubble Space Telescope at STSCI, the Space Telescope Science Institute, did a press release on particularly what they were interested in was these dimming events like Betelgeuse. And as a result, one of their artists drew a picture of what they think the star might look like. So that's the artistic impression. If you could take the obscuring dust clouds away, that maybe you would see something like that. Of course, you don't ever really see the surface of the star like VY Canis Majoris. By the way, I pointed out this dimming here. It seems to last a long time. Well, the star has still not recovered. Okay, it faded down to about 8.5 visual, and that's where it is still today. So there's a cloud of dust obscuring VY Canis Majoris. So the fun thing is when they did the press release about, particularly about the light curve, the title of the press release was Betelgeuse on steroids. So, yes?
Impacts anything and with any effect, or they just
Well, it probably with time, as you can see, this is probably what happens to some of them as they expand. It's like an outflow from the sun, like a coronal mass ejection. You've seen prominences on the sun. It's like that. Yeah. So that is after you look at that, look at these things, they look sort of like prominences, right? But they're not attached to the star. Basically, what you're seeing is the outflow, very likely. This is the leading edge of the shock, moving outwards through the other gas and dust surrounding the star. So that's the shape of the outflow as it expands away from the star. But there's an outflow, there is gas emission behind that, what looks like a shock wave here. So let's see here. How long? I should, the whole thing here is about 50,000 AU across. So it's big, okay? So it's been doing this for almost 1,000 years, been having these outflows for almost 1,000 years. Oh, and I was just, previous slide, that's what VY Canis Majoris look like on Hubble. And I forgot to emphasize that on these figures, you see these dashed lines here? They told you I had proper motions. So actually, we measured the proper motions of tiny little knots, which you can barely see here, very close to the star, but they are visible and they're actually discrete. If you zoom in on the image with Hubble, tiny little, like little dots right next to the star. But we were able to measure their proper motions and determine the age, that is when they were ejected. And so you see these dashed lines here represent the times when these dots were ejected. And the important thing is they correlate with the periods of dimming, just like in Betelgeuse and RWCPI. And the same is here. Some knots that were further away from the star were ejected sometime in the middle of the 19th century. So since then, since the Hubble work, we've been doing some collaborating with some radio astronomers, and they observed VY Canis Majoris with the ALMA. You've heard of ALMA? The big radio millimeter array up in the Andes Mountains, okay? Well, we got ALMA sub-millimeter imaging in the CO molecule, carbon monoxide molecule, and that's what VY Canis Majoris look like in CO emission, molecular emission. Now, that northwest arc that you saw in the Hubble image, that's right here. That's it. And here's a couple of those big arcs that are further away from the star. You see them still in the CO emission, but what on earth is that? We don't see that in the optical Hubble image. We don't see that in the infrared images. That is another, as you can see, major outflow of material seen in a molecular emission and also in the molecular continuum as well. And one of the things that we found is very close to the star right in here. This is what it looks like. That's the star right there. These are clouds of molecular gas. Well, we see them radiating in the emission from the carbon monoxide molecule, okay? So you see 4 discrete concentrations, different outflows at different times. Again, we were lucky. ALMA had observed VY Canis Majoris more than once. So over a period of observations, over a period of about 5-6 years, we again were able to measure the proper motions using the radio observations of these 4 separate condensations or knots, and we determine their ages. And once again, they are agreeing with this very active period for about 30 years in the early 20th century. Since these are emitting, we are able to actually estimate again their masses based on using some simple assumptions. We're able to estimate the masses of these knots. And what we find actually When you take these 4 knots plus the 2 or 3 we saw from the Hubble images, for about 6 of these knots, estimate their masses, and we sum them all up, the total mass in these knots is actually more than 7/100 of a solar mass. So approximately 1/10 of a solar mass was ejected by this star over about a 30-year period. So this is a lot of energy, and this is our analogy is with, as I said, solar type coronal mass ejections. So it's a very interesting phenomenon that's going on from these stars, and certainly driving their mass loss. But for you special tonight, we have some breaking news. Okay, maybe some of you have already seen this, saw some news releases and so about it, but Betelgeuse, of all things, might be a binary. 2 papers were published, actually only about a month apart, by separate research groups, looking at the light curves of Betelgeuse. Now, as a result of that great dimming, there's of course been increased interest in Betelgeuse, so lots of people are taking a closer look at Betelgeuse. But before talking about their results for Betelgeuse, I want to remind you, well, what about red supergiants and binaries? What do we know about them? Okay, well, they kind of come in a range. Most people nowadays, a lot of interest in binaries, interacting binaries, mergers, creating all sorts of interesting physics and so on that's unexplained, that makes a lot of headlines. So everybody thinks of binaries as things that are going to collide, they're going to merge, it's all going to be very exciting, etc. One of the stars is a black hole, and they merge with another star, or a neutron star, and whatever. And well, here's an example of one of those close binary systems, VV Cephei. Have any of you heard of VV Cephei? Amateurs have heard about it? Now, it's an interesting star system. It's a binary, an M supergiant, with a main sequence B star companion. It's a close interacting pair, so close that the secondary star, the B star, actually in its orbit goes inside the atmosphere of the red supergiant, and you get atmospheric eclipses with about a 20-year period. And in this case, the estimate of the masses, curiously, they're about the same. Both of them about 18 solar masses. But here's a more typical example, perhaps. You've all heard of Antares. You know it's a visual binary, right? Ever use it to test your eyesight? Okay, it's a visual binary, again with an M supergiant and a main sequence B star companion. Separation is about 3 arc seconds. That's at the distance of Antares. That's a little more than 500 AU apart. Masses have been determined from the orbit, estimated really. The problem is the orbit's rather long, has a period of over 1,200 years. That's actually, bear in mind, binaries come in a wide range. Got them when they're close and interacting, and you've got them when they're well separated, and anything in between. Majority of binary stars are well separated, and most of the binary star systems, the 2 stars are going to evolve as if they were single stars. So only if they're close that they interact with each other, do mass exchange, all sorts of other exotic things. So I wanted to put binarity a little bit in context when we look at Betelgeuse as a possible binary. First of all, Betelgeuse actually has 3 periods. The fundamental mode, or the pulsation period of 400 days, a first overtone to that pulsation period, and what's called the LSP, the long secondary period, which is over 2,000 days or about 6 years. Now, the fundamental mode is easily understood. That's due to the pulsation. I showed you that in that earlier light curve. You saw the regular pulsation period, the dashed line. The LSP, however, has been a bit of a mystery, and it's not the only star that has one of these. Other red supergiants do as well as AGB stars have LSP periods, okay? Well, a reminder, showed you this again to remind you, this is the fundamental mode. the 400-day period. Now here's the long secondary period. It's shown in the two different papers. Paper 1 by Goldberg et al. And paper 2 by McLeod et al. The upper figure here, that's the visual magnitude. This is the observed photometry you can see here. And this is the LSP. Okay. And down below here is the radial velocity as well. Radial varies in radial velocity, not by much. Look at that, only plus or minus about 5 kilometers per second. Very low amplitude radial velocity related to this period, the long secondary period. This is in the first paper. This is the second paper, just to show that the two groups are really working with the same data. They both have the light curve. They both have the radial velocity curve. Again, this is from the AVSO. It goes all the way back to 1920. And I think the earliest date on these people's period was 1995. But anyway, you see data covering very long periods. So they have a long baseline for their analysis. The radial velocities and the light curve are not in phase. That the minimum in the long secondary period, interestingly, occurs when the velocity shows us that it's moving away from us. The photosphere is moving away from us at the minimum in the light curve. That turns out to be an important point. So let's look at some results. This is the paper 1. They do an analysis of the light curve and the radial velocity curve. And what's interesting about that paper is they go through in great detail a number of possible explanations for the long secondary period. They evaluate each one, do some calculations, and come to the conclusion that yes, it is a binary with what they call dust modulation. The binary star in orbit around the primary. Betelgeuse is not a real dusty star. It's nowhere near VY Canis Majoris, but it does have dust, it has circumstellar dust. Okay, and what they're saying as the star orbit, the secondary star orbits the primary, Betelgeuse proper, it modulates or disturbs the dust along the line of sight. So their conclusion is that you have a low mass companion, low mass, that's interesting, that impacts the dust in the vicinity of the secondary star. And what you get is when the companion is in front of the primary, Betelgeuse proper, you actually, the observations show it be visually brighter because it's destroying or disrupting the dust in front of the star that has been obscuring it. And so when the companion is behind the star, that dust is now in front of the star and it looks fainter. So here's their model. Basically, here's the direction you're looking, okay? Here's when the star is, secondary is behind, okay? The secondary is behind, the star is, this is the light curve, and this is the radial velocity curve. And when the secondary is in front, you get it slightly brighter because they're arguing that it's destroying or disturbing the dust along the line of sight. And I should have shown you something you found interesting in the light curves. Okay, here's the light curves. That's the great dimming right there. And again, here's again, it's the great dimming. So does the secondary have anything to do with the great dimming? No. When the great dimming occurred, it turns out the secondary star was behind the primary. So it had no influence on that. Yeah?
Has the dust modulation been modeled?
Yes,
anywhere?
they do model it in.
Oh,
in the
and
paper.
it behaves as they expect? I mean,
Well, you know, as best as they can. Actually, the dust formation, I'll get to the result. I'll say something about on that result, okay? Okay, so paper 1, here's our results. Using the standard equations for binary orbits and so on. They actually end up calculating what's called the binary mass fraction. You see, the uncertainty in a binary is what's the orientation of the orbit? The orbit could be face on, like this. The star is here, the orbit's face on towards you. Or it could be in your line of sight, like this. So there's this possibility, there's a 90-degree range in the orientation of the orbit. Face on, sine I, few figures here, there's sine I right there, okay? Sine I could be in face on at 0. Edge on, line of sight, sine I is 1. The angle is 90 degrees. Well, they didn't have information on that, so their result is kind of limited by that unknown sine I. So there's a lower limit, and they get about a little bit more than 1 solar mass. And interesting, the separation only a little more than twice the radius of Betelgeuse itself. And here's the numbers for Betelgeuse. It's about an 18 solar mass star. Here's its radius, about more than 700 times the radius of the sun, or out to about 3.5 AU. Not as big as VY Canis Majoris, not as massive, okay? So that's their results. So what about paper 2? Remember, they're working with the same data sets, basically, light curve and radial velocity, but they added something, astrometry. Basically, a new astrometric solution for the period, for the position and looking for any evidence of periodicity in the position of Betelgeuse, and using some very high resolution images from 3 radio telescopes. They're looking for a signature of that LSP in the astrometric data, and they find 2 periods, one at 4.5 and the other at 6. So remember, that long period is about 6 years. And that solution is assuming for an edge-on orbit with sine I equal 1. So for them, here's their numbers, pretty much the same as the first group, of course, for the primary. And now that they have sine I, they can actually get a mass for the primary that's less than 1.25 solar luminosities. But they claim their best fit from the radial velocity is about 1/6 of a tenth. And again, separation is about twice the radius of the primary star. So there we have it, okay? What's Betelgeuse doing with a 1 solar mass companion? Most of the red supergiants we know of in binaries, it's a primary red supergiant, secondary, a main sequence hot star, a B-type star on or near the main sequence, with a mass ratio of about 2 to 1. It's typical. But here we have a mass ratio. Here's the summary for the 2 results. Again, very similar results, about 1 solar mass, maybe as small as 1/6 of a tenth of the solar mass, twice the radius of the primary, Orion A. Mass ratio, assuming these masses, as those are upper limits, mass ratio is about 20 to 1. It's located within about 2 radii of the primary star, the red supergiant. But what's the companion? What could it be? This is really not what we would be expecting around Betelgeuse. We expect to find another massive star as its companion. Okay, now we've got some limitations on that companion. One is the age. Assuming they're coeval, it's got to be can't be more than 8 to 10 million years old. Remember, massive stars don't live very long, okay? So, what is it? Anybody want to take any guesses?
It came from Betelgeuse.
It came from Betelgeuse. Well, it was formed at the same time as Betelgeuse. Assuming it's coeval, which would be normal for a binary system.
Well,
Hmm?
the moon's age is kind of close to Earth.
Yeah, but the moon's okay, it's a little bit different situation. All right, so here's the 2 possibilities. From paper 1, they're actually favoring that it might be a compact object of some kind. White dwarf is ruled out because white dwarfs are formed by low mass stars. A white dwarf is going to be, even if it was a high mass star, be a 5 solar mass star, a white dwarf is going to be several 100,000 years old, even 1 billion years old, okay? So it's ruled out. They think a black hole is ruled out because there's no sign of interaction between the 2. Even they're as close as 2 radii of Betelgeuse, 2 radii, there's no atmospheric eclipses. In fact, Betelgeuse has been observed many times in the ultraviolet. No emission lines, nothing like that. You might expect from thinking that close to a black hole, there'd be some kind of interaction. So they kind of focus that maybe it's a neutron star, which has implications. It means Betelgeuse a long time ago had a more massive companion, which quickly evolved more quickly and went supernova. The other people are actually favoring a pre-main sequence object because the time it takes, let's say, a one solar mass star like the sun to contract to the hydrogen burning main sequence is 10 million years. So they favor a pre-main sequence star, a cool star, one solar mass or less. And as they said, it was hiding in plain sight all along because similar in temperature to Betelgeuse itself. So that leaves us with, okay, what's the situation? But there's an interesting complication that may have implications for this explanation or support it. I don't know if you knew this, but Betelgeuse has a bow shock. As it's moving through the interstellar medium, its stellar wind, this is actually dust because it's imaged in the long wavelengths in the infrared, but look, it has what they call a bow shock. It's moving through the interstellar medium. Its material that it has shed in previous events or outflows is now colliding with the interstellar medium, and you see that impact here like this. So the problem is, okay, that means Betelgeuse is moving right along. It's moving pretty fast. In fact, they can calculate how fast it's moving because we know its position, we know its radial velocity, we have its proper motion, and that is enough to derive what's called the total space motion that it's moving, okay? It's total velocity with respect to what astronomers call the local standard of rest. I'm sorry, I'm getting technical, but that's galactic structure talk, okay? That's motions of stars in the galaxy with respect to our local standard of rest. It's moving fast, 29 kilometers per second. Now, most population one stars, young stars like Betelgeuse, a massive star, with respect to the local standard of rest is going to be 10 kilometers per second or less. So this star, something has accelerated it. Something's given it a kick. What might do that? The usual explanation is supernova. Okay, so that might support the idea that the companion really is a compact object from the collapse of another more massive star. Well, interesting. They've based on their orbit, they calculate the maximum separation, about 50 milliarc seconds. Now here you've got something separated by 50 milliarc seconds, where it's only 50 milliarc seconds from a star that is a luminosity about 10 to the 5th solar luminosities. And you're looking for something that probably has a luminosity of about 1 solar luminosity or less. How are you going to find it? Well, they calculated when these maximum separations will occur, and there was one in December, last December. Okay, well, that didn't stop that 50 milliarc seconds next to a 10 to the 5th solar luminosity star. Doesn't stop anybody. No, immediately they put in three separate requests for what we call director's discretionary time. They had these results in early fall, like September or so, August, September. So they had to rush to get their requests in to get director discretionary time. These telescopes are scheduled months in advance, okay? So they had to interrupt the normal schedule to do the observations on or about December 6th. Well, there are 3 separate proposals to 3 separate telescopes. One to obtain spectra with the Hubble. One to look for X-rays with the Chandra telescope. Why X-rays? Well, if you've got a compact companion, a neutron star, a black hole in there, you'd expect some X-ray emission. So they're going to go, actually, Betelgeuse isn't known as an X-ray source. It's not known to have any X-ray, but they're going to go look. Okay. And the third proposal was some imaging using the VLT, the big giant European complex of telescopes, and basically like an interferometer, and using what they call extreme adaptive optics and coronagraphy to search an image, find an image of the companion. So it's now been almost 4 months. What are the results? Well, I have a certain advantage. Right now, I'm not part of any of those proposals, but I have friends who are, okay? But I have a certain advantage because right now I'm editing what's called a special issue for publication, special issue on Red Supergiants. And two of my contributing authors are writing the review paper for the special issue on Betelgeuse, one of whom is Miguel Montarges. The other one is Andrea Dupre, who a name I mentioned earlier, has done a lot of work on Betelgeuse. And they actually asked, the deadline for submission of the papers was back in January. And I remember they said, well, we'd like to wait until we have the results. We want to put that in the paper, review the paper. We'll be one of the first people out with the results, etc. And they said, we'd like to submit in March. Okay, fine, I'll give them more time. All right, fine. Well, they submitted last week. Okay, and what was the answer? To be determined. In other words, my feeling is I've had the email exchange with them, et cetera, about this from several email exchanges. And based on the way the emails are going, I think the problem is going to be that the best they're going to be able to do is set an upper limit. If they had, if they had a detection jumping right out at them, it would have been headlines right by now. So they've had 3 to 4 months for analysis. And so that suggests they are working on their numbers, setting upper limits, very likely. And maybe with some more ideas about what that companion, the unseen companion might be. So I thought I would end there with your favorite star, your favorite red supergiant, Betelgeuse. Yeah.
They detect any X-rays or not?
It's not known as an X-ray source from previous work. Right. Yeah, but they're going to go look for them at that time when they have the maximum separation. Yeah. Okay, any other questions? I love talking about my favorite stars. Big
So-
ones.
So Jupiter's a red supergiant.
What?
I'm sorry, Betelgeuse is a red supergiant
Yeah,
and very active, right?
yeah, outflows, has
we-
active surface.
We've got at least 450 years now of meticulous observations of it,
Mm-hmm.
yet we just had the first big belching of material.
That they've seen,
that they've
that we've seen.
So in almost 500 years of really close record keeping. So why do you think that is? Why was this event so special in the scheme of, why didn't this happen before?
Well, you mean the outflows?
Yeah,
Well, it probably have, but even using the AAVSO website, and I looked myself to
Mhm.
see in their website on their look for any evidence, but there's big gaps. I mean, you look at the AVSL now, and there's all these nice, complete sets of observations because there's big teams of people like yourself keeping an eye on certain stars and reporting them, etc. That didn't really become the case before about 1970.
yeah, but,
so.
but the thing is with this particular one, I think Betelgeuse dimmed about a magnitude and a half. So it was something you could just look up and see.
Yeah, you could see it. Yeah, I
Right,
mean
I remember
yeah,
doing that.
so yeah, you could see it. I'll go back here. I mean, it was obvious if you knew what they look. If you were aware what Betelgeuse normally looked like, and particularly if you had a small pair of binoculars or even a small telescope, you buy at Target or something, you would see that. Okay, but there are big gaps. You go back before 1950 at the AVSO light curves. There are big gaps, holes in just about every star. Not everybody was busy looking at it. And unfortunately, being so bright, it's too bright for the Harvard plate collection I told you about that goes back to 1890. And before that, people were doing it visually by eye. Someone may have noticed that it looked fainter, but how well did all this get reported? I've checked the AVSO and I've noticed that there are a couple places in the light curve where I'd be suspicious it had a dimming. It looked a little bit fainter It wasn't it wasn't on one magnitude of 1.2 or 1.5 magnitudes that we saw recently. Looks a little bit fainter. It was consistent, but not that much. So there may have been some episodes like that. Okay, so I think that the Harvard Plate Collection will be the best place to look for other similar examples in other stars. After all, our WCPI I showed you already. We already have seen that the information in the Harvard Plate Collection for Vui Canis Majoris and AVSO shows those dimmings and outflows. So there's probably other red supergiants have been doing. Okay.
With these solar mass ejections, with some of our other sensors on the Earth for detecting photons and things like that, are any of those showing any blips or anything else, or is that something out of the scope?
From where? From Betelgeuse or?
Yes, from any of these, when you're picking
No,
up the
no,
solar
no.
mass ejections.
Well, there wasn't a whole solar mass. They were just a tiny fraction of a solar mass of ejections. Yeah. Mhm. Mhm. Okay. Okay. Any other questions? Well, I'm hoping as amateur astronomers, I've gotten you interested in watching Betelgeuse, if nothing else. You
So,
can't miss
so I,
it,
I
can
have
you?
a question.
Yeah.
Yeah, so the mechanism for the mass ejections, is it just because the outer layers are so tenuously held by gravity that it doesn't take much to drive it off, or is there?
Well, it'd be similar. See, that's the problem. It's like with the sun. We don't know why the sun has coronal mass
I was
ejections.
afraid you were going to say that.
It has to do with magnetic fields. Okay. It has to be, something has to be going on with the magnetic field. And that's the same case with the sun. They're still arguing about that one.
So you mentioned that we don't typically see small solar mass companions with supermassive red stars. Is there a physical reason for that, or is it conceivable
The
that there
contrast
could be
in light.
more of these?
Contrast in light.
Oh, okay.
You're talking 10 to the 5th solar luminosities with something that's only 1 solar luminosity.
Yeah. Is it conceivable that there could be more of these small companions, but we
It's
just haven't
possible,
detected
yeah. I
them?
mean, because the general rule of thumb is going to be you can see that secondary or its effect on the other star. So it has to be fairly massive and fairly bright. So that's why. I'm betting on all this interest in planets, What about a substellar object? Red dwarf. Something like that. Because they're getting down to some pretty low masses estimates there. Remember exoplanets? Most of them are super Jupiters, right? Yeah. What if you got something like that orbiting Betelgeuse? It'd be really cold, really cool, very faint. I just thought no one's mentioned that possibility.
I'd like to ask a crystal ball kind of question. It's sort of more pop astronomy. We read in the popular press and hear on the radio all the time that Betelgeuse is about to go supernova, that it will be next week or next year, or somebody today said 800 years. But the more sober press says sometime in the next 100,000 years. Has your work given you any feeling at all if this is going to happen on a human
lifetime?
civilization scale, or is it more likely many tens of thousands of years?
Well, for Betelgeuse, actually, some of the results on that. Oh, I went the wrong way. So, okay. For Betelgeuse, where we are, sorry, it's at the end. Based on these observations here and measuring the motions associated, measured proper motion associated with these arcs of ejected material, The estimate is that Betelgeuse itself it's a young red supergiant. The lifetime of a star in the red supergiant stage of a star like Betelgeuse, around 20 solar masses, will probably be, as I said, 8 to 10 million years. I mean, no, the lifetime in the red supergiant stage is about 1 million years. Okay, but the suggestion is that this material has been ejected from the star less than 100,000 years ago, which would suggest that Betelgeuse is a young red supergiant. Recently entered that stage within the last 100,000 years, so it's nowhere near going supernova. Now, I said that, and actually, the one that I have my hopes on is VY Canis Majoris. I'd love to see VY Canis Majoris do something dramatic. Well, before I leave this planet, so.
Thank you. That was a really good answer. I had no idea that you had that much information. That's great.
Yeah. Okay, someone had a question?
Yeah, I had a question about the imaging that they're trying to do on this. Could radio array imaging, similar to what was used to image the black holes recently, be used for this?
They haven't, something with ALMA wasn't proposed. Oh, I'm going the wrong way again. There's nothing in there with ALMA. So well, maybe there may be something about the radio observations and what they're predicting, and it doesn't work out. I don't know. Yeah. In the papers, they don't mention radio. They were mentioning the radio to doing it for the positional stuff. They were looking for small variations in that position that correlate with that long secondary period, and they found some correlation. But none of the, I brought the two papers with me. There's a lot more pictures here, figures, if you want to look at them. But they didn't say anything about radio in the papers. It may be they couldn't get on ALMA. They couldn't get rescheduled. So, any other questions? Like I said, I'd always like to appeal to amateurs, astronomers, to observe these stars. You know, most of these stars that I'm interested in are really fairly bright. They're not all naked eye, but they're not real faint stars by any means. I mean, of course, Betelgeuse, but RW Cephei, I think it's around 7th magnitude or so. VY Canis Majoris, a little bit far south, minus 26 degrees, 25 degrees declination. But, you know, here it is visually, it's 8.5. Photographically, 2 magnitudes fainter. Very bright in the infrared. If you want to have an instrument, not an infrared instrument, but maybe you work in the red region around, you know, near red, far red region around 6,000 angstrom. This thing is bright. So, and there's a lot more out there, and not just red supergiants. There are a lot of them, but another class of stars are very interesting to work on, what we call the yellow hypergiants, which are probably the descendants of the red supergiants. In case the star doesn't blow up as a red supergiant, we think it may have what we call evolution back to warmer temperatures before it goes supernova. And in that stage, it's a yellow supergiant, very large, very having lost a lot of mass as a red supergiant. It's going to be very unstable, and a lot of them are having what we call high mass loss episodes as yellow hypergiants. So very interesting. One of them is Rocath. I think it's a 3rd magnitude star. So, I mean, so they're out there. And one of the things I think a lot of people, particularly if all you hear about is galaxies and the early universe and AGNs and things like that, you may think everything's very faint. You need a real big telescope, right? You know, some of the brightest stars, the visually brightest stars in the sky, actually are intrinsically luminous stars. Okay. So there's a lot of interesting stars out there that are just going totally ignored. And one of these days they're going to do something. And nobody was expecting it.
We're due for a good nova.
Supernova. We are due for a supernova. We are way overdue. And so are M31 and M33. which are also in reach of your telescopes. The brightest stars in those galaxies are around 15th, 16th magnitude. So they're in reach of some of the telescopes that you people have. And when it goes supernova, it'd be really bright. Yeah.
Do you have a list of stars that you
Did I have
want
a
us,
list?
I mean, if you gave us a list, I'm sure there's somebody within this club or a few people within this club that would just watch for you.
Okay, Anton, you want to generate a list?
Anton, you have that list?
No, but
Cool.
he did his senior thesis with me. Oh, no, you did a special study course on spectroscopy with me. Yeah. So yeah, he can generate a list.
Hey there, one simple question, hopefully. What's the boundary between a supergiant and a hypergiant?
Well, actually, there isn't. I mean, we call a star a hypergiant. That's sort of the most luminous known supergiant. I mean, if you were to call it a supergiant, but if it represents the most luminous star known of that type, we sometimes give it the name hypergiant. Particularly if you look at their spectra, you can see they are extreme. And so it's also in recognition that many of those stars are highly unstable and they're losing a lot of mass. They've had high mass loss episodes, complex circumstellar ejecta, lots of dust, infrared emissions. So there's something special about them. Yeah. Cool.
Scutum, I think it's one of the biggest, it's even
Which one?
bigger. UT Scooty, Scutum.
There's an RY Scooty.
Maybe that's what it is.
It's
even bigger.
No, it's a
mostly-
binary.
No, I'm thinking of, again, one of these uber luminous, really massive stars. And I was wondering if
RY
that's on the
Scooty.
list of
Oh, there is a UV Scooty.
that. I think that's it.
Yeah. It's a red supergiant as well. Mhm.
Yeah.
Yeah. Yeah. Okay. Okay.
All right, well, Dr. Humphreys, thank you very much. All right, you're welcome. All right. Next up is Mark. Mark is going to be talking about Cedar Creek. Now, what we started doing last year is every site leader is going to do an update on their site, so their committee activities and everything. Cedar Creek is not necessarily a full-blown MAS site, but we have a very, very good working relationship, and it is growing. So we're almost acting as though it is a MAS site. So Mark, go for it. Oh, there you go. Forward back.
You're giving my show away. So Cedar Creek, I did some checking because I thought, well, it's been a long time since we started the Cedar Creek thing, and it's not that long ago. So we first had our first meeting thanks to John Popley's relationship before with them. He invited Caitlin Potter. I only know her as Caitlin. Call her Caitlin all the time. Dr. Potter. He invited her to one of our meetings, and I think that was either December or January of that 2018, 2019 area. And then all of a sudden, in February 2019, we went there, a group of us from the club. And I mean, we went there, we saw the property, and I think before the meeting was even half over, we already knew that we were going to have a star party there someday. We had no idea what the sky was like because we had the meeting in the middle of the afternoon, so we had no idea. So our first star party so our first meeting was February 2019. Our first star party was April 13th, 2019. And I believe that from my emails, and I was looking it back, it was clear that night. So that was probably the first clear night and probably was the last clear night for like 2 years, I think. It seems like it. I mean, we went on and on. Every time we had a star party, it was cloudy or rainy or snowy or something. And I remember once we had a star party there, we had to shovel off so that we could set up telescopes on their patio. Because it had just snowed like a couple days before. And that night actually was clear. It's kind of funny. We had to go work before we could even start. So anyway, that was the start of the relationship. And I'll tell you that it's incredible. We were just up there in February and had a meeting and got introduced to the new wing and all of that and all the bells and whistles that go with that. And I'll get into that in a little bit. But it's amazing that of what they're doing and what we've done for them and the relationship. It's incredible. So this slide is the facility as it is today. The original wing is the bigger building that's off to the right, and then that roof line runs east-west. So the roof line that you see closest to the left, that roof line that runs north and south, that's the new wing. And I just heard that they still haven't accepted it as final finish, ready to go, because there's still some problems with it that they can't sign off on it. So anyway, Cedar Creek, let's see the full name. Where is it? Cedar Creek Ecosystem Science Reserve. Okay, so say that like 3 times fast. And you can't, and if you make it an acronym, it even gets worse. So we just stick to Cedar Creek. Cedar Creek is on our Slack channel and all our emails and stuff like that. We always refer to it as that. So we have our star parties mainly in the Lindemann building, which is that first building I pointed out with the roof line that runs east-west. And I just sent an email out to the group that our first star party this year, this weekend, is going to be run out of there again because they planted grass and, well, the grass didn't grow and they got to replant the grass. So it keeps going on and on. But the new wing has expanded. There's 2 brand new classrooms in there. And they give us access to, they give us the key code to get in the building for every weekend that we're there. They may or may not be there, but we have full run of the building. We open it, we close it, we turn the lights off, we turn the lights on. We have everything that we want there, all the controls, and they trust us. And I go, yeah. Do you really know us? Have you really met us? No, I'm just kidding. But we take good care of them. Their main mission, is to educate. They do research. They educate public through public workshops that they have on site. They bring in K through 12 students to do education and stuff like that. Let me hit one more slide here. So they have all these plots out there. And with all those plots on their campus, it really isn't a fenced in, or there's no control. So, I didn't realize those were there until I really looked at this overview. And that's because there's no signage. The only signage that's out there when you go out there is a signage for places where us as the public can go without them. And they want us to. They want us to know what they're doing out there, what they're all about. So they're studying everything from animals to plants to reptiles, the whole bit. And they do tracking, they do bird watching and all that. And it's all about conservation and education. And their main point is to let people know that, we are damaging our planet, but to what degree? And they have information about that, and that's the research they're doing. And they really don't want us traipsing through the research because we don't take a very good care of our public areas anyway, and they don't want us messing up the research where it's basically untouched. But they do a lot of studies out there. I know that. see, I have another slide, education part. I mean, they got kids out there all the time. And what they're trying to do is they're trying to let all these kids that come through, because they're all basically from their backyard. Some of them I know are from the Twin Cities. And oh, by the way, this is a University of Minnesota property. The U owns it, they control it, they fund it. It's also funded by donations, all kinds of things. So the U owns it and they let us in there, obviously. And the education part is teaching us that come on their property, the kids that come on there, and anybody that's interested, and all their peers. So, I mean, they have, I'm part of their Facebook group and part of their Instagram group, and there's people coming there all the time, invited in. So they have also public programs for you and I. And they actually want you to come out there and walk their trails. They actually have 3 walking trails. Conrad, they have a ski trail out there. They have a ski loop out there. Who knew? One thing I don't know, and I tried to get Kara to answer me on that, is they used to have a herd of buffalo come in and hang out at their Oak Savannah pasture, and I don't know if they're coming out. They weren't here last year. I don't think they're coming again this year. From some of the stuff I saw, I was just going, well, do you know when? And I was going to kind of pass that on to everybody. It's at East Bethel. I have that in my notes, but I skipped that line. But it's up by East Bethel, so up County Road, up Highway 65, Minnesota 65. You get up to Bethel and East Bethel. Their address is East Bethel. They're just off of 65 on Fawn Lake Drive. And it's, I mean, you drive, and like most of us as astronomers, when we first set up our telescopes out there on the first night, and we went, wow, considering how close we are to the city and how close we are to other cities, we're kind of like in this little island where it's dark-ish. They also have a big program. Yeah, they do. Yeah. Yeah. So a comment in-house here was they have lunch with a scientist every month, and it's open to the public online and in person too. Oh yeah, okay. During the nicer weather months. So they do research, and the benefits that we get is we get to go hang out there. We have 5 star parties and a solar day scheduled. They actually are doing, we've done this for a couple of years. It works out really nice. The one year that Trina and I did it, it rained, it hailed, was cloudy, and it was sunny that day. So it was kind of cool because we had to cover up our telescopes and protect it from hail. John?
Do they have any solar observing program as part of their curriculum?
I don't know that. A part of their curriculum, I would say no. That would come from us. They would ask us to do that. And that only part of that program is when we do it on our solar viewing day, which is this year on September 27th in the afternoon, which is in conjunction with one of our star parties. All of our star parties are rain or shine. When it first started out, we would cancel them. And then we found out that then the next time that we had a clear night, then nobody'd show up because they didn't know we were there or not there. So we went, well, we'll just do it all the time so we can kind of create a following. And we do have a following. I mean, there is, I've heard Kara say, you know, we've had people out on other during the day stuff, and they go, we've been here for star parties.
My question is about how dark is that?
20 point something.
It's similar to ELO, maybe
Yeah,
a little bit
similarly,
lighter.
I think it's a little brighter because we're
Yeah,
there.
4 to 4.
Because
Yeah,
we're
4 to 4.
there, and the southern sky is obviously the metro area. We do
Looking
see-
north is good, east and west is looking good, but
Yeah,
just
west,
south is.
the only problem we
not
have
that
with
great.
west is the horizon isn't very good. We can't get very low, probably about 10, 15 degrees. east is awesome because from where you see Goldie here, to Goldie's back is east, and the tree line is like, must be like a half mile away. So, I mean, we get really good eastern horizon stuff. So hey, if you got any questions or anything, yes, sir. Hang on one second. Let me come back to you.
So I live in the North Metro, and I'm always looking for dark sites. Is this only available to us for the star parties? Or can we go up there, like at ELO on our own time?
You cannot go up there on your own unless you are part of the volunteer group, and get with me and we can talk about that and we can get you involved in that if you'd like to do that. And then, after you sign 1,000 waivers and make a bunch of promises and stuff like that.
So it
then
is a
you can-
growing relationship with
It is.
MAS, and we're looking really for the future. We've talked about a potential observatory there. Last year I presented about the Gertner 6-inch refractor that I restored. That's another possible site for us to put that historic telescope up there too. So that's still in talk mode at this point. So we're very, very early on. So
So
anything
one
else
last
there?
comment, if
Yeah.
you go up there and you use the trails, no dogs, no horses, no bicycles, no motorized vehicles, period.
Yeah.
So
So
respect their property because
Yep.
that's theirs and we're there as a guest. They're the host and we
Yep.
pretty much treat it as what they say goes, whether we like it or not. But I have found very little that we don't like about
Yep.
being up there.
just
Conrad's got a question.
all right. So just come up for a star party, try it out. It's a lot of fun. Bring your scope or don't bring scope.
So I noticed on the first picture that has kind of like a drone picture of the building, there's one of the buildings looks like almost like a little roll off.
No,
Well, the
no.
slanted roof there, see it?
No.
What is that? Oh, okay. Because it,
The shed.
okay, because it looks like it could be something.
All right. Thanks, Mark. All right. Yeah.
Actually, some of those buildings, people live in them. Researchers live in
Yeah. Research and student people live there. Okay. We're moving on. We're kind of running out of time. So let's go through the rest of the slides here. So one thing that has come up recently is we're getting a lot of requests for outreach, and traditionally we've been using the forum, and we've got a core group of people doing outreach. So what we're doing now is we'd like to consider expanding the outreach and actually giving Lila and getting a bigger voice, a bigger team, more resources to do outreach. So if there's anybody who wants to volunteer to be on a more formal outreach committee and help organize the materials in the outreach bins and expand the outreach to the Slack channels and do other things like that. So please email anyone at the board or info@mnastro.org. That'll get to the board. So basically, we want to upgrade the level of service that we can get for outreach. So please volunteer for the outreach committee. So all are welcome, and we're looking for help there. So all right. Then presentations. So another thing that I've been talking about, I've been requesting presentations from members, and we have a presentation today from one of our members. It will be a little bit different. So basically, we're still requesting presentations. So if you've got any kind of observing projects, anything fun you're doing, some tourist stuff that you're doing, what are you laughing about, Trina? So tourist stuff in the astronomy realm, please put together a presentation and present it to us. We're all interested in what you're doing and what your projects are. So Craig Waynard, let's see what you've got for us. Forward back.
Got a few minutes here. So this is Craig Weiner cosplaying Nicholas Copernicus. So there's lots of diversity of what we consider astronomical outreach. People on the sidewalk. Here's actually one from 1905 New York City with probably an F-15 refractor. I think that's Dave Faulkner giving a outreach at ELO. And in fact, this is another outreach I did here. This was November 11, 2019 on the steps of Kauffman Union at the University of Minnesota. It's obviously during the day. Anybody know what I was showing the students? November 11, 2019. The transit of Mercury. Yep, that's a student there. And I dragged my 6-inch Dob out to the Kauffman Union and showed maybe 20 or 25 people the transit of Mercury. Then there's something, which way does this click here? There's the Renaissance Festival. Renaissance Festival has been in the Twin Cities since the early 1970s. Their goal is to recreate a 16th century England-like fantasy kingdom. It runs over 8 fall weekends. They get 300,000 visitors and they have over 750 performers. This is in Shakopee. Anybody been? Okay. And as you know, these are the performers in the middle. They're all dressed up. And then the people who come and pay money to come in, about 70% of them just come in regular summer clothes. And actually about 25% dress up as various characters. So it's an opportunity to come and dress up like a performer or a character. Well, if this is the Renaissance Festival, why not talk about a Renaissance man? And Nicholas Copernicus certainly fits that criteria. He was a mathematician. He was a classic scholar, an economist, trained as a physician. He had a doctorate in church law, so he was actually Dr. Copernicus. And he had many high positions in church and state up in the Baltics. This is basically where Poland is now, Gdansk, that area. And of course, he was an astronomer. That's what we know him as. And this was all before telescopes. So I said, I'm going to go to the Renaissance Festival and dress up as Nicholas Copernicus. And there I am. I'm dressed in, this is a doctorate robe. This is what, if you were at Oxford or Cambridge, you would walk around with all day. Now, when we go and get graduations at university, we dress up as, for one day a year, but this is what they wore all the time. These are my 2 daughters dressed up as a maiden, and the other was dressed up as a peddler. And the point is, you make your own costumes and everything. And you can't see it, but she has a backpack there in the peddler, and she made all that by herself. This is a close-up view of what I wore. Again, this is a doctorate gown. I did have a tiny little, spyglass refractor, and no one said that's an anachronism. Copernicus never had a telescope. And then what I did is 2 other things is I cut out a cardboard image of the whole point of the Copernicus theory, which is the heliocentric theory. And this is taken from his The Revolutions of the Celestial Spheres in 1543. And you can see there Mercury, Venus, the Earth with the little moon around it. Then you can see Mars, Jupiter, and Saturn, and they actually have their the Roman numbers for their period. So the period is for Saturn is 30 years, for Jupiter is 12 years. But then at the very end, of course, that's the stars. That's the crystal spheres that the stars rotate around. And I don't know if anybody has noticed, the real people who know about Copernicus, that's the sun in the middle, right? But notice it's not exactly in the middle. So here, my wife was taking some pictures. Here's Craig trying to waylay some people. I was not a paid performer. This is, you just dress up and then you harangue people to say, hey, I'm Nicholas Copernicus and stuff. And so here I am talking to some, I don't know, thugs or something like that from medieval England. And here's a young lass I'm talking to, and then some other interested people looking on a little bit doubtful. And so here's the typical interactions I get. Number 1, they think I'm Galileo. Okay. So obviously for the English peasants and Vikings that tend to come to the fair, the only person they know is Galileo. Uh, yeah. And the second thing they said after Galileo is, you're a heretic. Okay. So they knew that Copernicus kind of introduced a thing which some people in various religious areas didn't like. And, they were like, go like this, and, we're going to burn you at the stake. Now, of course, they didn't realize that Copernicus died right around the time this was published. So he never got in trouble personally because he wasn't around anymore. In fact, Galileo did get in trouble, what was this, 60 or 70 years later, mostly because he was talking too much about the heliocentric theory and got involved in politics about who was going to be the next pope in Italy. And he was Italian, probably spoke too much, used his hands too much. And he got into trouble with that. That's why he was put under house arrest for a long period of time. There was many astronomers who believed in the Copernicus theory and never really got into any problems. So one thing I would say is you can create your own astro outreach. I mean, I was the only person there doing that as far as I can tell. You can do this anywhere. Character creation is fun. You read a lot of things about Copernicus, so you are prepared to answer questions, although the level of questions they got weren't very difficult, of course. Well, the plan for 2025 is, should I go as Galileo? I could have my same little telescope and no one would object to that. And I could be planned like being burned at the stake or something like that. Might make it a little bit more exciting. Or should my real favorite actually is Kepler, also around the same time, 1619. That might be a little bit more complicated, a lot of math and equations and everything like that. I can make a little tip and say I was, in a duel and my nose got cut off. People would probably like that. That was Tycho Brahe, but they were buddy. Huh? Yeah, a little bit too much. So for instance, again, here's another interaction. Again, these women, I don't know whether they're paid performers, they just like doing this. They were basically dressing up as the three weird sisters, Boyle, Toil and Trouble in Macbeth. And so I let them do their thing, and then I went up to them and did my thing. And this is the way the interaction is at the Renaissance Festival. So fun and games, any questions? Yes. Nope, I just show up, do my thing. I have considered you can become a performer. I mean, you see they have little stages there. I'm not talking about, puke and snot, thing like that. Those guys are professionals. But they do have things where people, they do song and dances for a half an hour. But I think you have to commit to being there like pretty much every weekend, and, it gets hot and stuff like that. The other possibility is actually bringing like a solar telescope and, doing Copernicus or something like that and say, yes, but you can see here's the sun that's in the center of the world. That's a possibility. I probably have to get permission from them to bring something in like that. But they want people to be entertained. Yeah. Yeah, I could bring a Dob and say this was invented by Isaac Newton. Yep, that's a good idea. Any other questions?
All right, thanks, Greg. All right, I'm just going to quickly run through the last slides. Loaner Scope program. I know Anton's here. I'll just speak to it. So loaners are available. They're coming in and out. Anton's handling them. You go on the website. You fill out a form. Anton gets in contact with you. Makes arrangements to pick up scopes. We got Dobbs, refractors, solar scope, binoculars, and also a whole range of DVDs available. So really good collection. All of the list of all the scopes and all the DVDs are on the website. So fill that out. Remember, that's a perk of the membership, and it's really nice now that observing season is starting. All right, weekly happenings. Claire's done a great job getting it out every Tuesday. So we get all the latest news and things that are coming down the pipe for MAS. So if you have anything to post in happenings, send it to secretary@mnastro.org by the end of the week to get to the following. Friday night, we'll get it into the next Tuesday's happening. So online communities. So we've got our Slack community, we've got our forums, the website, of course. We are on YouTube. This meeting will be edited and put on YouTube, as well as all of our VSIGs, Zoom presentations. So that library is growing quite well. And of course, we have our social media, Instagram, Facebook, and Instagram, Facebook. I guess that's all we're doing these days. And YouTube, of course. So if you want to send Chris Bethia, our social media coordinator, an image, you're welcome to do so, and she will post that. We recommend that you watermark your images and take credit for those images. So send it to socialmedia@mnastro.org to get it there. Slack is a great tool. I just noticed there's a discussion right now. Dave Roberta said something on Slack and is asking if anyone wants to get together and talk about spectroscopy, because I know that was a topic at the last BSIG. So Dave, if you're here, raise your hand, and he's out there and back. If you want to get together, now's a good opportunity to do that. So. All right, our merchandise is still available on Cafe Press. We are still working on upgrading our graphics and all of that stuff. So hopefully in the next month or two, we'll get that going. But this is the official MAS merchandise, hats, mugs, shirts, and everything. Gemini, as you know, Father Brown does a great job putting together our club newsletter. The entire Gemini, from the history of since day one, has been written by club members for the club. We don't take outside content and regurgitate it. It's all original content by club members. So very great resource. All the back issues are available online, and the entire online database is searchable. So if you're looking for an article that was written in 1986, you can type that in and search any kind of keywords in that search box, and it'll find it. All right. Other public service announcements. There's some books in the back. Jerry Moriarty donated a box of books, so please take them home. I don't want to take them home, so we really want you to do that. There's some other random stuff up there. There was a tripod. I think it's already been taken. We also have several telescopes that have been donated, and John Zimmich has posted them onto the MAS forum in the marketplace. There's a Meade 10-inch LX100 and a Meade 10-inch LX200, and there's some other stuff also to come on the forum at very attractive prices. So they're very nice scopes. John has set them up and tested them. Got any questions about them, talk to John, but they are available, and the sale will go to benefit of the club. So if there's anybody else have any other PSAs? All right, if not, Astronomical League. So unfortunately, I contacted Jerry. He has nothing to say this month, but I have recorded Jerry. So what does Jerry always say? Let's see if it works this time.
Get out there and observe or image.
Yay! What's that? And
get out there and observe or image.
Yes. More time. All right, NCRAL convention. So finally, I want to note that the convention is April 25th to 27th. It's still available, so ncral2025.org is the website. You can see exactly what the program is going to be, but they're going to have an event April 25th at ELO, and with observing and a barbecue there. They have vendor displays. They've got a bunch of speakers from the University of Minnesota. Bob King is going to be there. Larry Rudnick, Clem Pryke, Evan Skillman, and then Greg Bragg and Mike Benson also will be speaking there. So I also got a notice from NCRAL that they are looking for officers and additional volunteers. So if you would like to be part of the North Central Regional Astronomical League, those volunteer positions are available. So if anyone has any questions about that, you can contact me or contact the AL or the NCRAL. All right. So next meeting is May 1st, 2025, right here, 7 p.m. And don't forget, tonight we are meeting at Pizza Luce for those interested in meeting. So thank you everyone for coming, and have a great evening.